Okay, here we're going to look at how to make your home more energy efficient. Right, they tend to look at different aspects of your home and see as to how we can save money. And of course, this is important because we're trying to save you guys money and obviously trying to stop us wasting energy and contributing to global warming. So we're going to look at the main ways in which you can insulate the house. The main ways are double glazing, cavity wall insulation, loft insulation and draft excluders. There are other ones, we'll come back to those in a second. Let's examine each in turn. If we look at double glazing, what you've got there is basically 2 panes of glass. Okay, those black lines represent 2 panes of glass, and in between it there's a partial vacuum. They've taken out some of the air and they've replaced it sometimes with another air. Now they can't take out all of the air, because if we did that, the windows would implode. So what effect does this have? Well, on the left hand side it's inside the house, and the outside is on the right hand side. So the inside is warmer than the outside. So to start with, it's a glass, and because glass is an insulator, it finds it difficult to get through the glass, but it still will do it. So A represents conduction through the glass. When it reaches B there, you'll get convection. Now because there's a lot less particles in there, it is not so good at doing convection. In addition, because there is a very narrow gap between the panes of glass, there's a lot of friction in there, and it makes it very difficult for the air to circulate up and down on that side there, because basically the currents sort of interfere with each other. And so by having a narrow gap there, you can actually cut out a lot of convection. So B is reduced convection, and of course once the outer layer of glass is reached, it conducts through that. So what double glazing does is it slows down the process of heat going from the inside of the house to the outside of the house. Cavity wall insulation works in a different way. So if we go to the bottom here, this time the inside of the house is on the right hand side, the outside is on the left hand side. We're looking at the bottom one here. So the heat inside the house will conduct through the wall, and when it gets through the first wall, there's a gap then between the inner wall and outer wall. The reason there's a gap there is basically if it rains on the outside wall, it won't soak through to the inside wall. That's the reason there's a gap there. Now, so the heat's travel through A by conduction, and of course then you've got a big gap in the middle, and of course the heat will then do convection. It will heat up the air in there and it'll start to do convection, and then it'll go through C. So it's very similar to double glazing this, except you can't evacuate the air from the inner and outer wall for 2 reasons. First of all, there isn't a seal there, but if you could get a seal, the walls would collapse in on each other, they would implode. So what we do instead is we pack that cavity wall, that cavity space, with fiberglass or foam, and those bits of foam and fiberglass stop air moving around, and what they do is they actually trap bits of air. We'll see that a bit more clearly in a second. So cavity wall insulation, a very good way of keeping your home warm. Finally, loft insulation. If you look at the loft insulation, if you go into the loft, not suggest you do it, please don't do that because you'll fall through the roof sometimes. On the left hand side there, you can see I've drawn a picture there with those little red squiggly lines and brown bits, and that's supposed to represent a lampshade. And in the loft you'll find there's a massive thickness, normally around 15 to 20 centimetres of fiberglass stuff. It actually gets into your fingers, it's actually quite painful. And what fiberglass does is it basically traps little pockets of air. You can see that in the green circle I've drawn there, which is supposed to represent like a microscope zooming in. And the fiberglass traps pockets of air, and pockets of air are fantastic insulators. They're better insulators than the fiberglass themselves, and it's those pockets of air that actually stop the heat from escaping from the house. If the air gets heated, it tries to do a bit of convection, but because the gaps are so small, the pockets of air are so small, it's very difficult for convection to take place there. So that's how fiberglass works. It works by trapping air in the same way, for example, that your clothes trap a layer of air. In the same way that feathers and a bird trap layers of air, that it's the air that actually is the insulation, not so much the fiberglass. The glass itself is an insulator, but nowhere near as good as the air. So that's how that works. Other energy saving device you can do is you put shiny phones behind the radiator or in the walls or ceilings. That will reflect infrared radiation back into the room. An insulation jack around the hot water tank. You probably find you've got a big plastic foam thing around your hot water tank at home. Carpets stop heat escaping by conduction through the floor. Thermostatic valves are basically, they allow you to control the temperature in each room, and if the lower you set them down, the more energy you can save. And perhaps the most effective way is if you wear more clothes, you'd be amazed as to how less you need to use heating. Now, you need to know about payback time. Okay, and whatever you do, do not say is the time it takes to pay back the cost of something, because you're just repeating the question. So you need to say that payback time is the time, you can't avoid that, the time it takes for the savings from putting in insulation equals the cost of installing that. Okay, so for example, we've got a good example there in pink. It costs £600 to put loft insulation, shall we say, and if it saves you £300 a year, the payback time is 2 years. At the end of 2 years, the savings you've made, which is £300 a year, will equal £600. After that, of course, you're saving £300 every year, which is good. And I've got some other examples just down there, just zooming in there. Double glazing, for example, is notorious, very famous for having a very long payback time, about 40 years. Draft excluders pay back themselves very, very quickly because they're very cheap. Finally, you need to know about U values. Now, the exam board may talk about U values, and what is a U value? Well, it's a number, and that number, the lower the value is, the better the insulator it is. And it's the amount of energy flowing every second, I should say second, per meter squared per degrees Celsius temperature difference. Okay, that's the definition of U value. It's the energy flowing per second. Now this diagram tries to explain it, just to the left of this. Okay, what we've got there is that blue box is supposed to represent let's say a pane of glass, shall we say, and there's a temperature difference of 20 degrees on the inside, 19 degrees on the outside, and it's a meter squared. Okay, so we've got the standard unit of area, we've got the standard temperature difference of 1 degree C, and then what you do is you measure as to how much energy goes through there every second, and that says 3 joules. So this would be shown as 3 watts per meter squared per degree C. So it's basically a measure of working out how good something is at being an insulator. And that there is everything you need to know about your house, the cost of heating your house and how you can save money, and also U values.